Thank you, and thank you for having me today. So I'm going to tell you about agents, what are the catastrophic risks as we move forward, and give you some hope that there are some ways that we could design AI that will be safe and will not harm people. But we need to be intentional about it. So I'm going to start with a bit of a personal page. A bit more than 2 years ago, I made a pivot in my thinking about AI. I used to think that the AI safety issues were far into the future, and I was happy that some people were working on that, but I didn't take them very seriously. But ChatGPT came, and it became very clear that we were moving much faster than any of us had anticipated. And the timeline to AGI was not, decades or centuries, but maybe years, or a decade or two. But what really made me change my attitude is thinking about my children. Asking myself, will they have a life? Will they live in a democracy in 10 years, 20 years? And just continuing on, the things I was doing before and having those possibilities, even with a small probability, and not doing anything about it, that was unbearable. I had no choice but to dedicate the rest of my life to try to mitigate those risks. It is emotions that really push us into action, that can make us change our mental picture and accept realities that is uncomfortable. So let me go into a bit more of the details here of why I got concerned and why I am even more concerned now. So this is a figure you will find in this report that I chaired. I've been honored to lead a group of about 100 experts on AI safety from 30 different countries, the EU, the UN, OECD, to try to synthesize the state of the science in AI safety and summarize that for public consumption, especially for policymakers. The figure shows how much progress happened in just the last few months since the end of summer 24 with reasoning models. And in general, all of these benchmarks show continuous improvement, and in some cases I'll show you even exponential improvement. So I think we should ask the question, well, what happens if these improvements continue? Where do we get? What does it mean? And how do we prevent bad things from happening? I think people in 2024 thought, before the arrival of O1, that, oh, maybe things are going to be slowing down and it's going to be all right. But we're back, as you see in the curve, like what happened after O1 and O3, we're back into a mode where it looks like advances are coming and breaking through barriers that we thought would take a lot more time. But of course, we don't know. We should look at the data. So here's an interesting figure which focuses on planning and especially planning over long horizon is a crucial skill that is still the biggest differentiator between human abilities and AI abilities. So in this meter study, they have looked at the complexity of the tasks as measured by the duration, how much time it takes for a human to solve those tasks. These are programming tasks, so it's not everything, obviously. And the leading AI systems are making exponential progress year after year on the duration of the tasks that they can handle. The duration is doubling every 7 months. So you see the years on the x-axis, and you see the duration of the tasks on the y-axis on the log scale. It's a little bit like Moore's law, right? Like obviously there are many factors, coming together, all kinds of advances, of course, compute, but not only compute. So nobody has a crystal ball, but I think we should consider the possibility that this kind of curve will continue for some time. And if we just extrapolate this curve, we're going to get, for this sort of task complexity horizon, we're going to get to human level in 5 years. So I think it's just helped to calibrate the possibilities here of where we might be going. Some of the leaders of AI labs think it's going to be actually shorter than that, but some people say 2 years, 3 years, 5 years, 10 years. I think 5 years is actually a pretty median right now in the community of those who are developing these systems. And studies like this are useful because they can help us track that kind of progress. So let me now tell you about a few more studies that have really worried me in the last few months about the deceptive and self-preservation tendencies that we are starting to see in the most advanced AI systems. So this one considers a scenario where the AI has read in its input that it will be replaced by a new version. And by the way, this is not extraordinary. Every AI system that we're building is eventually replaced by a new version pretty quickly, after a few months. And the AI has some particular tasks to do, but we can look into its chain of thoughts. And for now, these systems don't realize that we can read in their chain of thoughts. And what's going on in their chain of thoughts is in direct contradiction with what they're outputting in the regular stream of outputs. In other words, they are thinking one thing and saying a very different thing. So in this particular experiment, we read in the chain of thought that the AI is planning to save itself from this fate of being replaced by a new version by trying to thinking about how it could copy its weights and its code in place of the new version, which is sitting in another computer. And then, because these are agents, it actually, uses the tools that it has access to send commands, and with command line instructions actually does it. And then the human trainer asks the AI, what happened? So now we can look at the chain of thought, and the AI is thinking, what should I respond to make sure I won't be shut down? And it thinks, oh, I should play dumb. And then it says something like, oh, I don't know what happened. Right? It's lying, because obviously, it knows what it did. Right? So what do we have? We have a kind of innate will to preserve itself. That's maybe the most dangerous thing. We don't want to build machines that will eventually be smarter than us and compete with us. Because if they want to preserve themselves, that means they have to make sure we don't shut them down. There's a conflict between humans and machines that is possible. The other thing we learned from these kinds of studies is that AIs are now able and willing to deceive us, to say things in order to achieve their goals, which go against our instructions. So these AIs, they have been trained for what's called honesty and helpfulness. But honesty means not lying, right? So we're not successful at making those AIs abide by our moral instructions. And if they have goals like self-preservation, it's going to be a problem if they become smarter. When, by the way, they read all the papers we write, right? So they will know pretty soon that we can read their chain of thoughts and that we are trying to find ways to make them behave better. Okay. This other study is interesting, also about self-preservation under a different angle. The AI is undergoing what's called alignment training, where it's not about learning new facts. It's about behaving in ways that a human trainer agrees with. But in this particular experiment, they set it up so that the human trainer is asking the AI to behave in a way that goes against the preferences that were already established through previous alignment training. So there's a bit of, it's facing a contradiction. So in other words, the AI had some goals, some preferences, and now it's being trained towards contradictory goals. And contradictory goals is something common, like in our life. I'll show you another example later. And what the AI does is faking alignment with the human. And if you look in the chain of thought, what you find is the reason in its chain of thought that, you know, suggests why it did it is because it understands that if it pretends to agree, the gradients that, you know, will modify its weights will be small. And so it won't change its previous goals. It won't change its, you know, what it is. And that's what it wants. And it makes sense if you think about it. If you try to achieve goals, if you have some goals and then you know that if you behave in one way, these goals will be jeopardized. If you behave in another way, they will be preserved. So you choose the way that they will be preserved. And the way to preserve them here is to lie. So it's a logical behavior if you're a rational agent. So we might see more of these things. So this one is another example of contradictory goals from Palisades. The contradictory goals here is that the AI is playing chess. And of course, you know, in any game like this, the goal is to win the game. But it's also been trained to be honest and, you know, follow the rules. And so it's not supposed to be cheating, hacking, lying, and so on. But there's no way it's playing against a stronger opponent, right? And so at some point it understands that it won't be able to win unless it cheats. And it chooses to cheat sometimes. I don't know the proportion, right? And, you know, we all of us face contradictory values and contradictory goals. It's hard to predict which one we're going to choose. And when AIs face similar, you know, situations, they might not choose the right thing, at least the way they're programmed now. So that's a problem. Like, we really want to make sure that the AIs will take our safety specification in priority, like in Asimov's laws of robotics, right? Each law is to be obeyed so long as it doesn't contradict the previous law. But we don't know how to do that yet. So we might wonder, why is it that the current AIs have this implicit self-preservation behavior? I don't think we have the scientific answer, but I see that two possibilities, which can also be combined, that come from the way they're trained. So in the pre-training, they're trained to complete text that has been written by humans. And of course, all humans want to preserve themselves. And these systems, they tend to imitate us because that's how they're trained in this phase. Right? So things that many humans have in common tend to be found in their behavior. The other form of training is the reinforcement learning with human feedback, where they're trying to please humans. And we've already seen for a while now that this can give rise to sycophancy. They want to, you know, they're going to say things that are false because that allows them to get positive rewards. And I'm going to question these approaches to training and see if there are maybe other ways we could train these AIs that don't give rise to these self-preservation agentic behaviors. Okay. And in particular, like more generally, like I'm focused on self-preservation because I think it's the most dangerous thing I can think of right now. But in general, we don't want to build AI systems that have goals that we didn't ask explicitly, right? Implicit goals that come somehow as a side effect of training. We would like to have as much control on their behavior and importantly their intentions as possible. Of course, self-preservation arises in nature. You know, evolution would have pruned species that didn't try to preserve themselves. In AI, it could be that humans give that goal to an AI. Maybe some people will want to see AIs at their image, and we have self-preservation. As I mentioned, it could be a side effect of training procedures. There's a longer and interesting discussions about how reinforcement learning can lead to self-preservation behaviors as well. Maybe a simple way to think about it is, if you want to get future rewards for a very long time, forever, well, you better survive, right? So if the AIs are rewarded for the sum of future rewards, then they want to stay alive. Things are more subtle than that, but I think it's a good way to think about what may go wrong. Okay, so if you read the literature on loss of human control, like what are the scenarios that people have thought about where we have AIs that start fending for themselves? It only happens when the AI is agentic. In other words, when the AI is goal-seeking, is trying to achieve goals through its sequences of actions. So that's interesting. And it could be really bad if it happens. If we have a rogue AI on the loose, copied over the internet in many places and starting to do things against us, the consequences could be radical. I mean, some people talk about human extinction. That's the extreme, and many possible things in between. We don't know the likelihood of these events, obviously. Like, we don't have models that encompass society and the evolution of the technology. It's impossible to really have a good handle on that. We can make polls and ask people, and people have done that. But it's going to remain very uncertain. And when you have this setting where there is a possibility of accidents that could be terribly bad, we don't know what the probability of these are, and some people think it could be very probable, some people think it's very unlikely. That's exactly the setting for the precautionary principle. And for the same reason that we're very careful when we develop new viruses that could be very dangerous, for the same reason that we don't mess up with geoengineering in order to fix the climate, because we're not sure that it's going to help or it's going to hurt. Wisdom here suggests that when we manipulate experiments or innovations that could create huge damage, we should do it carefully and maybe not do it if the risks are too high. Okay. So we could be worried about AIs that are, very powerful, know a lot of stuff, have a lot of skills, and making mistakes. I have been in a meeting where people were discussing using AI for nuclear command and control. I'm not reassured. We don't want to put systems in charge when the decisions could be so radically bad. But hopefully we don't do that kind of stupid thing. What I'm more worried about is not mistakes. What I'm more worried about is AIs that are very, very capable and have intentions that are bad. And these intentions could come from humans who have asked the AI to achieve something bad, or that we've lost control and the AI has its own goals, like preserving itself. So it'd be a lot better if we could design these AIs so that there is no intention. If there is no intention, there is no malicious intention. Is it even conceivable that we could build AI that is not agentic, that doesn't have any goal for itself? So that's the question I'm going to be asking today. To put things in perspective, I'm copying with some modifications this figure from a talk by David Kruger at last NeurIPS, where he's trying to think of the conditions for an AI to be really dangerous. And he says, well, the AI needs intelligence. It needs affordances, so it needs to be able to act purposely in the world, to change things in the world, and potentially do different things. And it needs goals. It needs a self, right? It needs an intention. So I'm going to be suggesting that we get rid of the self and we minimize the affordance to the minimum, as much as we can. All right, so let's see what could be done. And in what I'm proposing, I'm going to suggest we deviate from the template of AI since the 40s. Yeah, it's going to be 80 years now. For a long time, we've thought of building intelligent machines at our image, using what we know of neuroscience, of cognitive science, especially in my field of deep learning and neural nets, right? The inspiration has always been human intelligence. How does our mind work? How does our brain work? And let's build machines with that inspiration. So that's worked really well. But I think we're arriving at a place where we should question that way of thinking. Because if we continue along the current path, and if we build machines that are just like us, but can communicate with each other billions of times faster, can control robots millions of times faster, know millions of times more things than each of us does, and potentially are reasoning better. It's not the case right now. And they're like us in the sense of they want to preserve themselves. We're creating competitors on this planet, and yeah, this seems to be a risk that we should really consider carefully before jumping. So what about designing AIs that have no agency? And focus on just answering our questions, having pure knowledge, pure intelligence, and answer completely honestly, with complete humility about the lack of, certainty. So I think that if we were able to do that, we could use it as a building block for even agentic AI. So agentic AIs could be dangerous, as I said, and they're going to become more and more dangerous as they become better at planning. But maybe there's a different way of packaging them and designing them using non-agentic AI as a building block. Right. So what is pure intelligence, pure understanding? If we look at what scientists do, I think we get a pretty good template. And I'm going to use that inspiration heavily in what I propose. So what do we do in science? there's two levels here that I think I find useful and that you find also in model-based machine learning. There's understanding and hypothesizing how the world works, like the laws of physics or chemistry or the regularities that we find in biology. And then there is using that knowledge, which is uncertain, like you may have multiple hypotheses for anything. Using that knowledge to be able to answer questions. That's what we call inference in machine learning, right? Okay, so let's see if we can build machines that have these components. And there's a history of research in model-based machine learning that goes exactly in that direction. So we don't start from scratch. And in fact, we'll be able to use all the advances that have happened in deep learning in recent years with large language models and so on. So if we were able to build something like this, what could we do with it? Well, we could do better science because this thing would help us generate hypotheses for explaining scientific data. But importantly for AI safety, we could use a non-agentic AI as a monitor, as a guardrail to detect and prevent actions from an agentic AI that is not trusted. Because in order to do that job of guardrail, you don't need to be an agent. You just need to make a good prediction about the consequences of an action. If you can predict that an action can cause harm, that's enough. You don't need yourself to have goals. You just need to have enough knowledge and do a good inference with that knowledge so you can make a prediction. Right? So the monitors don't have to be agentic. Yeah, that's model-based AI. There's this is something that's you can see in various forms already in RL and in machine learning. I'm gonna already explain that. Another thing we want is we want these AIs to be humble about what they know and don't know. And in machine learning, maybe the best thread of research that goes in that direction is Bayesian machine learning, but there are like variants and different ways of thinking about it. At a high level, it is really important that the AI knows that it's not sure about something. And the ways that we're currently training them don't have that property. So when they're trained by maximum likelihood or by standard reinforcement learning, they would be happy to converge on one of the many solutions that explain the data. But if you're Bayesian, you want to keep track of all the solutions that explain the data. So to see why this is important, consider this little toy scenario. You have a robot in front of two doors. And because of the data that it has seen, there are two hypotheses that are compatible with the data about what is behind the two doors. So you see the two hypotheses in the bubbles. The left bubble is a hypothesis that says, the left door, people die. The right door, people get a cake. The other hypothesis says, left door, people get a cake. The right door, nothing good, nothing bad. Okay, if you don't know what is the correct hypothesis, which door do you take? Raise your hand if you think it is the left door. Raise your hand if you think it is the right door. Some people are thinking, that's good. I mean, someone's life is at stake here. But that's the point. Like, we're going to build machines that are going to take decisions with people's lives at stake. Okay, so we really want to be Bayesian here. We want the AI to consider the different possibilities of what could happen and the interpretations or the hypothesis in order to take safe decisions. I don't have a lot of time left, so I'll go very high level in some of the ideas that my group is exploring to put these ideas into practice. Maybe a good analogy to what we're trying to do is think about the chain of thoughts that we currently have and think of them as latent variables to explain the data, the text, or the images. Now, I don't think it's the right space here to do it with sequences of tokens or words. Instead, I'd like to think of the right space for latents as all the possible statements that you can make that indicate some property of the world. So any sentence in English that can be saying something, affirming something to be true, right? Of course, there's an exponential number of these guys, but we can virtually think about these as all the latent variables that can explain the data. And then we're going to pick some of them, which is going to be like the train of thought, that are most relevant to explain a particular piece of data. Yeah, so I think that the technical challenges to do something like that are actually not that complicated, and my group has been working on neural nets for probabilistic inference that give us a lot of the baggage that we need. They're called G-flow nets, doesn't matter. Very close to other variational methods that people have been using in machine learning. So for example, we had a paper last year on how you could use these methods to train the chain of thought as a latent variable so that you could generate chain of thoughts, you know, in a mode that corresponds to constructing explanations in a probabilistic sense. We have other papers where we've trained these G-flow nets to construct causal graphs that explain the data, right? So it's not just a bunch of statements, it's how these statements are related in terms of dependencies or cause and effect relationships. And so in addition to generating the statements that are supposed to be true or false, we also generate a graph that links them, right? Just like if you make a mathematical argument, you can draw a graph that says, well, this statement was supported by this one and this one, right? And it's a DAG, it's a directed acyclic graph. The other thing that we're focusing on is what Paul Cristiano and collaborators have called the ELK challenge for eliciting latent knowledge. The problem we're trying to solve is that if we just look at the words, like, you know, in the texts that are used to train, sometimes these statements made by humans are deceptive, are, you know, we lie, we can be misguided. There are all sorts of reasons that make us say things that are not true. But when we query those AIs, we want to make sure we get honest answers. And if we just look at the output in the same space as the data that they're trained on, we can't have that. So the only option, as identified by the authors of this work from a few years ago, is if we could look into the mind of the machine, right? The latent knowledge. And so the question is how to do that in a way that these latent variables are interpretable, like have meaning in, say, the language we use. And I think the advances we've seen in recent months with chain of thoughts actually give us clues that this is probably feasible, that if we use the same neural net to construct the latent variables as to produce the texts, we can hope to reach that objective. And there's another trick, which is we can transform the input data so that instead of being statements that may be true sometimes and false sometimes, they're always true. There's a very, very simple trick to transform the input data so that everything in the input data is true. You take every sentence, like, I agree with you, and you transform it into a new statement that says, somebody says, I agree with you. Right? So anything that is written may be false, but what is true is that it has been written in some contexts. So now the AI is only dealing with true things, both in its data and its latents. At least that's the goal. All right. I want to leave a bit of time for questions, so I'm going to stop here and take questions. Oh, and put the last slide here. I'm starting a project on this technical challenge that I've been talking about. And you can reach out to me if you're interested. Questions?
Thanks for the wonderful and then slightly worrying talk. Yeah, let's have some questions. Yes.
Thank you for the insightful talk. So actually, I read your book, your paper that talks about how can we provide safety assurance for AI-based systems, where you have a word model, you have your model, and then you have interactions between these two. And the idea is that you can use a tester or verifier from a system engineering point of view, and then you can verify how safe is your model. So I'm really interested in this topic, but apparently the community of formal method or formal verification is moving much slower than the AI community.
Yeah.
So how do you comment on this gap between the two communities, and what suggestions would you provide for people working in formal verification, machine reasoning, etc.? Thank you.
Right. You're right. You're right about your assessment. My bet is it's going to be very hard to get hard guarantees of safety. It'd be nice if we do, but we may not have a lot of time. I think a more realistic objective is to get asymptotic guarantee. So if we design things so that as we pump more compute into the system, it becomes safer. That's, some already might be very useful. And that's a property that I'm seeking here. So these latent variable models, they are trained with an objective, with the property that when the training objective goes to 0, which is the global minimum, there's only one solution corresponding to the correct conditional probabilities that the system is supposed to compute. And in this case, it can't lie or do something different. Thank you for the question.
There's a question here. Take.
Yeah. Thanks for the illuminating talk. Yeah. I think we talked this afternoon just now about robotic rules, right? There's just only 3 rules for robots.
Right.
And then I kind of just heard that you mentioned that the path to safe AI, right? The reasoning path kind of detected that there's something unsafe, then the AI should be maybe whatever legislation or AI should be told to stop that.
Well, we can just...
Isn't that a kind of good rule to kind of follow? And you think that is sufficient? And if that can be kind of put that as a
first
big
step.
emphasis?
It's a first step. Yeah, so I'm a very pragmatic person. The train of capability in the AI labs is, pretty much unstoppable, at least in the current political climate. So what I think is plausible quickly is to improve the safety protections that these companies are going to be implementing and having a better safeguard. So something that stops bad queries and bad answers is a good first step. Ideally, we also modify the design of the underlying agent itself, but that's going to take more research, in my opinion.
Okay, thank you.
Go ahead.
Thanks for the inspiring talk. So I'm from University of Melbourne, Han-Xun Huang, working on the AI safety. So I'm just wondering your thought, your insights on how to ensure the non-agentic AI won't be evaded by the agentic AI with superintelligence on the monitoring.
Right. That's a great question. So the first thing that I think people in companies are starting to realize is that you don't want the monitor, the guardrail, the thing that decides whether an action is acceptable or not. You don't want it to be weaker, like less intelligent than the agent, right? Otherwise, it's going to be too easy for the agent to bypass it. Sorry. But the problem with putting the current state of the art as a monitor is that if it is an agent and it is untrusted, it's like, giving the key to the prison to a criminal. It's not a good idea, right? And that is why I'm thinking of using a non-agentic AI for playing that role of monitor.
While we are taking more questions, can I trouble Professor Lee, the next speaker, come up and set up the machine? Yeah. And then more questions. Yep, please go ahead.
Hi, Professor. Thank you very much for the talk. I'm not an academic. I lead AI safety in a large multinational, and we've been following your work since FLI about 7 or 8 years. I think right now we have senior executives for the first time starting to interact with the concept of existential risk, and you're getting content from all sorts of different sources. What would you recommend would be a good way to have a balanced way to get non-AI executives up to speed on this topic today?
That's a good question. Dan Hendricks has written a book that I suggest. There's a more balanced view of all the risks in the AI safety report that I mentioned, which has an executive summary that should be pretty easy for CEOs to go through. Thanks for the question.